It's a strange thought, but have you ever wondered if you could somehow, I don't know, mix all the light in the entire universe together, what color would you even get?
It does sound a bit out there, doesn't it?
Right. But it turns out scientists have actually looked into this. And the answer is this. Well, this surprisingly poetic thing called cosmic latte.
It is, and that's what we're diving into today, isn't it? The story behind that name and the science.
Exactly. It's this mix of, like, serious astronomy, but also cosmic history, maybe a little philosophy, and honestly, a bit of humor, too.
It's a concept that really stretches the mind because you look out there, you see all this incredible variety, these vibrant nebulae, different colored stars.
Yeah.
The idea of one single average color feels almost wrong somehow.
Totally. You look up at night, you see black, mostly, with little pinpricks of light. Then you see these Hubble images just bursting with blues and reds and gold. So, yeah, if you blend all that starlight from every galaxy, what's left? It's clearly not just black.
Definitely not black. And it's not quite those super vibrant processed images either. The reality is, well, more subtle.
And the scientists who figured this out, Carl Glazebrook and Ivan Baldry, finding this color wasn't even their main goal initially, was it?
Not at all. Back in the early 2000s, they were deep into studying how galaxies form, how stars are born over cosmic time, big picture stuff.
Right.
And finding this average color was almost like a fascinating side effect of that larger research and an unexpected discovery.
Okay, so how on earth do you measure the average color of the universe? You can't just get a giant cosmic paint bucket.
No, not quite. But the method is pretty elegant, actually. You have to think about the light itself. The light arriving from any galaxy isn't just one thing. It's a whole spectrum of different wavelengths, different colors, all mixed together.
Like a rainbow, but for a whole galaxy.
No, sort of, yeah. And that spectrum acts like a fingerprint. It carries information.
Information? Like what?
Oh, loads. What kinds of stars are in the galaxy, how old they are, what elements they're made of, even how fast the galaxy is moving away from us. It's all encoded in that light signature.
Wow. So Glazebrook and Baldry, they looked at these fingerprints from how many galaxies was it?
A lot. Their survey, the 2DF Galaxy Redshift Survey, gathered spectra from over 200,000 galaxies.
200,000.
Yep. A massive sample. And what they did essentially was average all those individual light signatures together. Imagine digitally blending, 200,000 different color palettes.
Okay, I can picture that. And the first result they got was a bit off, wasn't it? Something about green.
That's right. Their initial paper in 2002 reported the average color as a kind of pale turquoise or greenish white.
Greenish white universe. Doesn't sound quite right.
Well, it shows how science works, right? They realized there was a slight issue with how the software was handling the color correction, specifically with the reference white point.
Technical details.
Exactly. So they reanalyzed, corrected for it, and published an update fairly quickly in 2003.
And the corrected color was?
Much less exotic, much more, beige white, a very pale beige.
Beige, okay, so cosmic latte.
Yeah.
But it's not just about finding the universe's official paint swatch, is it?
Yeah.
What does this beige color actually tell us?
Now that's the really cool part. This color is a direct window into the history of star formation in the universe.
How so?
It's all about the dominant types of stars. Billions of years ago, the universe was much younger and more energetic. Star formation was happening like crazy.
Right.
And the stars being formed back then were often massive, incredibly hot, and very, very blue.
Blue stars, okay.
These blue stars burn super bright, but also burn out relatively quickly, cosmically speaking. So back then, if you could have averaged the light, the universe would have appeared significantly bluer, like a cosmic baby blue, maybe?
This universe started out bluish.
Pretty much, yeah. But as time went on, those massive blue stars lived their short lives, exploded, or faded. Meanwhile, smaller, cooler, longer-lived stars started to dominate.
Like our sun. Yellowish?
Exactly. Stars like our sun, and even cooler, redder stars, red dwarfs, red giants. These stars emit more light towards the yellow and red end of the spectrum.
So over billions of years, the overall mix of light shifted.
Precisely. Fewer bright blue stars forming, more older, redder stars sticking around. The average color gradually drifted away from blue through the yellows towards the redder end.
And landed on beige?
Yes. That pale, beige-white cosmic latte is the average color now, reflecting this long history. It's a blend dominated by the light from these older, more reddish stellar populations, but still with some contribution from younger blue stars. It's like a snapshot of billions of years of stellar evolution.
That's actually kind of profound, a single color telling such a long story. You mentioned going back, what about way back, before the first stars?
Right after the Big Bang. Well, then it was just an incredibly hot, dense soup of plasma and radiation. No stars at all. Too hot.
Just energy?
Essentially, yes. High-energy radiation. Then, as the universe expanded and cooled over maybe a few 100 million years, gravity pulled matter together, and the very first stars ignited. And those first ones, mostly those massive hot blue giants we talked about.
So it went from radiation glow to blue and slowly shifted towards the beige we see today.
That's the progression. And interestingly, a lot of the stars that contribute most strongly to today's latte color seem to have formed around maybe 5 billion years ago. There was a major peak in star formation back then.
Huh. Around the same time our own solar system was forming.
Roughly. Yes, it connects back.
Okay, and you also mentioned something about our viewpoint from Earth affecting the color slightly. How does that work?
Right. So when we look at very distant galaxies, we're seeing light that has traveled for billions of years to reach us.
We're looking back in time.
Exactly. We're seeing those galaxies as they were when the universe was younger and likely bluer because they had more of those young, hot stars.
Okay, I follow.
So the light mixture that actually arrives here at our telescopes on Earth includes a bit more blue light from those distant ancient galaxies than perhaps the true present moment average across the whole universe would have.
So from our perspective, it looks a tiny bit whiter or bluer than the true beige.
Yeah, just a touch, yeah. It's a subtle effect, but it's there. Our observation point matters.
Which makes sense. Now the name, Cosmic Latte, it's just perfect. How did they land on that? It doesn't sound very official scientific jargon.
Oh, definitely not. Glazebrook and Baldry didn't name it in their paper. They realized it was kind of a fun result, something people could connect with.
So they crowdsourced it.
Pretty much. They put out a call for suggestions. I think it was through a Washington Post article initially, and people ran with it.
I bet. Were there any other funny contenders? You mentioned some earlier.
Oh, yeah. There were some great ones. Let's see. Big Bang Beige, Astronomer Almond, Unforgettable Khaki.
Khaki Universe.
Hey, yeah. And my personal favorite, Primordial Clam Chowder.
Primordial clam chowder. Seriously, where did that come from?
Who knows, but it's memorable. There was also Cappuccino Cosmico, leaning into the coffee theme.
So why Cosmic Latte? What made it stick?
Well, several things. It's simple, it rolls off the tongue, and it actually does evoke that pale, milky beige color pretty well.
True.
Plus, there's a nice little subtle connection. Latte is Italian for milk, which connects to Galileo, the great Italian astronomer.
Ah, okay.
And it also hints at the Via Lattea, the Milky Way in Italian, so there are these nice little historical echoes.
That's clever.
And as the astronomers themselves joked, maybe there was just a bit of a caffeine influence among the team making the final choice.
Huh. Probably needed after analyzing 200,000 galaxies. So, okay, it's a cool fact, great name. But what's the sort of deeper meaning here? Why should we care about this cosmic average beige?
Well, beyond the science, it works as a really powerful metaphor, I think.
How so?
Think about it. You have billions and billions of incredibly diverse galaxies, different shapes, sizes, histories, full of unique stars and nebulae. Just mind-boggling variety.
Yeah.
Yet, when you average all their light together, you get this single, relatively simple, harmonious color. Cosmic Latte. It kind of represents this underlying unity beneath all that cosmic diversity.
Huh. The ultimate blend. I like that. Unity
Right.
and diversity.
Exactly. It's a reminder that everything out there is interconnected, part of the same grand system contributing to this overall hue.
And that connects to us, too, right?
Possible.
Because we're part of that steam.
Fundamental point. The elements that make us up, the carbon, the oxygen, the iron in our blood, were forged inside stars. Stars whose light contributes to that cosmic latte average.
We are stardust, as they say.
Literally. So understanding the universe's color, its evolution, is understanding our own origins in a way. Our connection to that whole cosmic story.
It makes you think philosophically, too, doesn't it? Like you mentioned perspective earlier.
It does. If we were observing from a completely different place in the universe, say inside a really young galaxy full of blue stars, would our measured average look different?
Probably, yeah.
It raises questions about how much our specific location and time influences our perception of the whole. Is there even one true average color, or is it always relative to the observer?
That's a bit mind-bending. So Cosmic Latte is our observed average from here now.
That's Perhaps the most accurate way to put it, yeah. It's the average light reaching us based on the observable universe from our vantage point.
Okay. And this whole idea, cosmic latte, it seems to have caught on beyond just science circles.
It really has. You see artists using the color or the idea to explore themes of unity or the vastness of space. Poets have written about it.
Finding beauty in beige.
Minding beauty and the meaning behind the beige, I think. It's that subtle shade that represents everything. It's made philosophers think, too, about, blending individual perspectives into some kind of collective understanding.
It shows that something doesn't have to be flashy or dramatic to be profound.
Precisely. There's a quiet awe in it. The beauty of the aggregate, the average representing the entirety.
Wow. Okay, so from figuring out star formation and to accidentally finding a color to naming it after coffee and ending up with metaphors for unity and our own existence, that's quite a journey for a pale beige color.
It really is. It's a fantastic example of how a scientific finding can ripple outwards and touch on art, philosophy, and just our basic human curiosity about the cosmos.
Well, this has been genuinely fascinating, a really rich deep dive into something that sounds simple but clearly isn't.
It's a deceptively simple concept with layers upon layers of history and meaning baked into it.
So maybe the next time you're looking up at the night sky or even just, having a latte, take a second to think about that pale beige. Billions of years of stars, galaxies, all blended together into that one color. A reflection of, well, everything.
It definitely adds a different perspective, doesn't it? Makes the universe feel both incredibly vast and strangely unified.
It really does. Well, thanks for exploring that with us. Hopefully it's given everyone listening something new to chew on.
Always a pleasure. The universe is full of these surprising little corners.
Absolutely.
Yeah.
So, until next time, keep looking up and stay curious.